Today we are going to start with a new library from data science, and the library name is Matplotlib. In the last lecture, we covered pandas. Pandas is used for data analysis purpose. So in which we have seen the 2 points series, and second one is the data frame. So series is one-dimensional data structure, whereas data frame is a two-dimensional data structure. Okay. Today in this lecture, we'll start with the Matplotlib, which is a data visualization tool, and it is a library again which is built on the top of NumPy, and we can use Matplotlib effectively for plotting different types of graphs. Today our main focus is on 2D plots like line plot, scatter plot, box plot, hist plot, okay, pie plot. So rather than numbers, data, we are interested in information. So when we process the data, we get an information. When we represent the data, we get an information. We can draw a conclusion from it. We can inference something. And this is nothing but what is a data science, right? So guys, if you want to explore more about the Matplotlib, so I can suggest you just visit this official website of Matplotlib, matplotlib.org. And you can go here. You have different options like plot types, examples, tutorials. Okay. If you visit the tutorial, then it will give you in-depth options like quick start, then pipe plot tutorial. If you want to go with the image tutorial, customization of Matplot with different figure aesthetics, styles. So you can go for it. Okay, so this website is an official website of Matplotlib, which you can refer for exploring the things in detail. Okay. So guys, the library is Matplotlib. And actually from this Matplotlib, we are going to use a pie plot model. Okay. So from a Matplotlib, we are going to use a pie plot model. So I'm going to do what? I'm going to import Matplotlib dot pyplot as PLT. Okay. So we are importing the operations present in a pyplot model. Pyplot model is a part of Matplotlib. Matplotlib is a data visualization library present in a data science umbrella, and we are calling it as a PLT. Okay. So this PLT is nothing but a shortcut alias we are using for importing a Matplotlib and pyplot along with. Now guys, in today's session, the basic plots we're going to see are as follows: line plot, then we'll see scatter plot, okay, then bar plot, then bar H, which we can call it as a horizontal bar plot, then hist plot, then pie plot. Okay, these many plots we are going to observe. Okay, now in order to create a plots, we need two things. As I'm going to focus on a 2D plots. Okay, our focus is on 2D plots. So we require two things. Which are those? The first one is independent variable, which we call as an input, and second thing is dependent variable, which we call as an output. So independent variable means input variable on the basis of which we can get something, we get some result, we get some output, right? So for 2D plot, we read these two things. In normal convention or calling convention, we call it as X, and we call it as Y. So the independent is on X-axis, and dependent value means output value is on which axis? On Y-axis. So this is just a convention we need to understand first. So if I want to plot any graph, now before going ahead guys, in plotting, we have different types of options available. Okay, so you can say the analysis has different types of analysis. Like the first one is univariate, second one is bivariate, third one is multivariate. Okay. Univariate means only one input is responsible for giving you the plot. Like hist plot, pi plot, KD plot means kernel density estimation plot. Okay, even box plot also. Let me add here box plot. Box plot also a univariate plot. Okay, line plot line plot is actually univariate, bivariate, and multivariate also. Scatter plot is bivariate, bar plot is bivariate, horizontal bar plot is also bivariate, hist plot, pi plot, box plot are univariate plots. Okay, so bivariate means two or we can say one input plus one output. It is nothing but a bivariate. The multivariate means more inputs in one output, or we can also have multiple outputs. So guys, using Matplotlib, these plots are possible. Means we can have univariate plot, we can have bivariate plot, we can also have multivariate plot. Actually, multivariate plot is connected with the Seaborn mostly. I'll show you that example also. So let's start with the line plot. Okay. For example, I'm having a now the temperature is it's like a summer. Okay. So we are going to plot a temperature data. Okay. So plot temperature data. Fine. So let's say I'm having a temperature data, and I'm going to mention just a temperature data for 5 days. Last 5 days temperature data. Okay. So I'm going to put a random values here. Let's say we have 27, 29, then 30, then let's say 19, okay, and 20. It's 5 days temperature. I'm having only one input right now. I don't have more than one. Okay, means one input, one output like this. I don't have anything. So in order to plot this, I'm going to use line plot. Okay, line plot. So using a PLT, how we can plot a line? In this PLT, we have different options available for different plots. So for line plot, we have PLT.plot. And in this plot, if you supply a temperature, which is your input, so how the graph will be plotted, guys? This is a list. And what is the property of a list? The property of the list is list has indexing concept. So obviously, each number is having an index. So 27 is having an index 0, 1, 2, 3, 4. Okay. So when we are supplying only one data like temperature, so index acts like x-axis value and the actual values will lie on y-axis. Let me repeat once again. The index of each number will be on x-axis and the values will lie on y-axis. Means temperature will be on y-axis. Okay. So if I execute, you will get a data like this. See. So guys, I can conclude, means I can at least analyze. So on day 1, we have this temperature. Day 2, we have this temperature. Day 3, we have this temperature. And day 4, we have this temperature. So on day 3, we have noticed the lowest temperature on day 3, whereas on day 4, it bit increased. But before day 3, on day 2 and day 1, okay, even actually here the 0 means what? This is day 1 actually. It's a day 1. 0 means day 1. Fine. So guys, total how many values we are having? We are having 5 days value. Okay. But as you can see here, default it is starting with the 0. So it is dividing this x-axis scale into 0.5. Okay. Okay. So 0.5 times like 0.5 plus 0.5 plus 0.5 in this way. You're getting the values on the y-axis. Okay, we can change also. I'll show you. But the thing here to understand, on y-axis what we are having? We are having a temperature. On x-axis we have index. We have index. Okay. Suppose if you supply here, let's say the values like this. Let me show you. Day 1, day 2, day 3, day 4. And day 5. If I execute, then there will not be any problem. You can clearly identify on day 1 what was the temperature, On day 2, what was the temperature? And day 4, we have the lowest temperature, and we can analyze here. Fine. Now in the same example, guys, I'm going to change. You can see the default color we are getting here. It is a blue color. Fine. But if I want some other color, let's say I want here a magenta color. Fine. So I can write here color is equal to magenta. I'll execute. So I'll get here a magenta color like this. Right? Default, you are getting here a line which is a solid line. But if I want to display this line in other format, okay, so I want to change the line style. So what I'll do, I'll again copy this code. Just I'm taking simple separate code line to make you aware about in each cell what changes I'm performing. Huh? That's the only reason. Otherwise, you can change in the same code again and again. No issue. Fine. So the next thing is what? It is about line style. So I want to change a line style. Rather than a solid line, I want a dash dash. I want which style? I want dash dash line style. I'll execute. So at the place of solid line, now you will have a dash dash line style. Understood? So guys, again, if you want to make some bullets available in your graph, so those bullets can specify the intersection point. Okay, means on day 1, this intersection point. On day 2, we should have here the intersection point. So when I want to highlight the intersection point, then we'll take the help of marker. Okay. So next thing is highlight intersection points using marker. So again, I'll put a comma. I'll use here a marker, and we'll use a marker like O. O is used for a circle. So execute, and guys, you can see now the marker is available, and that marker is representing an intersection point of each segment x and y value. Okay. So guys, now your next requirement is I don't want the line in between. If you want only markers to display here, yes, you can do it. No problem. So if you want to remove the line style here, keep the line style empty. So now only the markers will be available. So what will happen, guys, in this case? Only markers will be printed. Okay. See. Now only markers you are having here. Now you don't have a line. Only markers are available. Okay. Guys, there are a lot of figure aesthetics properties associated with the Matplotlib. Means I know you might have questions, sir. Can I change the background? Can I change the outer lines? Can I change the scale? Can I change this? Can I give the heading? Can I give the title to the whole graph? Can I add multiple graphs together? Yes, absolutely we can. But within a 2 hour, the maximum thing I'll try to cover here, and I'll show you how we can analyze the data. Now just for 5 days data we are having, but still we can conclude various things. So so you can see that from day 1 the temperature goes on increasing. So on day 2 again it increased. On day 3 again it increased. But from day 3 it is gradually decreased by 10 degrees Celsius. Okay, so means from 30 it goes below 20 actually. So this is what an analysis we call, right? So guys, I'll keep the graph as it is. Fine. Now my requirement is this is not a complete graph yet. I want to add the values to the x-axis. Means I want to put a label to the x-axis. I want to put a label on y-axis. Again, I want to give the title to this. So we'll use plt.xlabel. Okay. So on x-axis, I want days. Okay. On y-axis, I want plt.onLabel. I want what?
Temperature.
Okay. Now I'll put a title 5 days temperature data. Okay. 5 days temperature data. So I'll execute. Now you can see you're having the x-axis label as a days. On y-axis we have temperature, and the title is 5 days temperature data. Now we are not able to understand what this line indicates. Okay, so in order to indicate or in order to give the identity to this line, we have another attribute here. So we can mention label, and I'll write here day wise temperature. Day wise temperature. So about this line, I want to provide an information. So I'll write here label is equal to day wise temperature. If you want to make this label visible, so another option you need to go for legend. Okay, so you can use your legend. So now clearly you can understand this is about 5 days temperature data. Day wise temperature, this is indicated here, and on x-axis we have days, on y-axis we have the temperature. Okay, so guys, the default styles are present, default things are available. So how you can identify and from where you can get the information, means like this, what it contains. Now I know what is marker, what is label, but if you want to explore more about the plot, then I'll tell you the shortcut. I already told you. You just use your plt.plot, put a question mark, execute it. When you execute by putting a question mark at the end, you will get an information about the plot. So this is the plot y versus x. So we have a lines, or we can have a markers, and if you just go below, then you can see the different options here, x comma y, then y. Okay, and so many options are available. See, line width, marker size, color, marker, line style, line width, marker size. Multiple options are available. Even if you just go below, then you will get again more information about it. See, I'll go here. So it will tell you what is the x and y, what is FMT, data, and below you will get an example and its properties. So you'll get here properties like alpha, then clip box, color, and so many options are available. See, fill style, okay, fill style, then line style, line width, marker color, marker edge color, marker face color. So if you want to change the marker color, so you can change the marker color using marker face color. If you want to change marker size, you can go with the marker size. So all these options are available. Even you can see the which type of markers are available. So these many markers are available: point marker, pixel marker, circle marker, triangle marker. Okay, these many markers are available. So you can explore just by looking the information you will get in the page. Okay, after executing this, so then it will give you all information about plot options. Okay guys, now as I said, this is a just a graph for 5 days. Suppose if I want to add a graph of let's say again let's say previous month data I want to add. So can we add multiple plots together? Means can we mix the two plots in one graph? Let's see. So I'm going to use this option as it is. Okay. So this is the first plot, and then I'll again add another plot, plt.plot. Again, I'll just add here second thing. Okay. So day 1, day 2, day 3, day 5, I am going to keep as it is. Just at the place of temperature, what I'll do, guys, I'll supply the new data here. Directly I'm supplying. You can also take the variable, and that variable you can supply here, but I'm going to supply directly value. Okay. So I'll give here 18, then 20. Okay, so let's say 35, then 33, okay, 90. Again, 5 values you must need to supply for 5 days. So again, it should match. Okay, we cannot supply more or less value here. Now color which I want here, let's say green color. Okay, line style I will put here. I want a line style, let's say solid line I want. So I'll just put a dash. I want a solid line. Then marker. Suppose if you want a different marker, you can add a different marker. Let's say if I want a star, I'll add a star. So just a small changes we are doing, guys, here. Okay, and we'll execute. You can see the 2 plots in a single graph. 2 plots in a single graph. So the plotting is very simple, but it gives you a meaningful information. It gives you various things which we cannot understand by just looking at it. So images are a very powerful tool for analysis. Okay. Now we combine 2 graphs. Again, the same thing you need to do means if you want to give here, let's say what this green line is about, what the pink line is about. So you can again add the label. So let's say January 2023, and this is the data of, let's say, label I'll write. Label is equal to December 2022. Okay. In order to make them visible, what we'll do? plt dot legend. Fine. This is the case. Okay. So pink is about January 2023. Green is about December 2022. Now, if you want to save this figure, then also it is possible. Okay. So mostly what we do, we right click and we go to the save image. But when you do this, your image resolution will not be kept as it is. So if you want a good resolution image, then I would suggest you go with the plt dot savefig. Okay, you go with the plt dot savefig, and in this savefig, you need to give the file name. Where this file name will get stored? Right now, when we give the direct file name, so where our file is present matplotlib, at the same location as we have seen in the last lecture, your file, image file will get stored here. Okay, so I'll write here temperature dot, let's say png. There is another term which is a DPI. DPI stands for dots per inch. So if I want good resolution, then I will increase this, let's say 300. Okay, so I'll save this figure. Fine. Now you save this figure. So if you just go to the MIT and you can see the temperature.png created seconds ago. And if you open this, so you will get a figure with good resolution. See. Okay. Fine. So this is a huge because we have option zoom here. Okay. Now you can see this is your figure. Okay, guys. So using DPI, we get a good resolution. It gives a good resolution. Fine. See, if you zoom it, then there is not an issue in reading it. Okay, so good resolution you will get. Even suppose if you want, let's say the grid lines, you want to be inserted inside. Okay, so we can use here plt dot. Okay, plt dot grid. And if you execute, then you will get the grid lines in it. You'll get a grid lines in it. I think I executed this option. What did it be? Fine. Next, I want to show you how to insert the grid line. You can insert the grid line using plt.grid. So guys, a lot of things we can do in the image itself. But this is just an example of which plot? This is an example of line plot. And line plot is univariate, it is a bivariate, as well as it is multivariate. So for multivariate, we need a huge data again. So we can plot it again. Means with respect to the other column, we can increase the size of markers. So according to the category also, we can increase the size of marker. So then we call it as a multivariate plot. Now, as you may say, when we are having this plot, okay. So the default size we are getting here, this one. Okay, this is the default size. So suppose if I want to do the size manipulation, means I want to increase the size, I want to decrease the size. Is it possible? Yes, absolutely it is possible. How it is possible? PLT dot, and then I'll use your figure, okay, and in this we need to supply fixed size, and I'll supply here the fixed size in terms of tuple, and in tuple we need to supply width and height. Okay, so suppose if I want a block of 4, 4, okay, so width and height I'm keeping the same. If you execute, guys, you'll get a small block. If you increase this, let's up to 18, and if you increase here, let's say 14, you will get a big figure. See, okay, it's a big now. Again, you can increase the font like on the x-axis, on the y-axis, we can increase the font. But usually we don't require this, na. So what we are doing here, we are using a fixed size for just making the manipulation or changes in the figure size in default size. Okay, so we can do like this. Now, this after a line plot, the next plot which I'm going to explain with you is nothing but a scatter plot. So scatter plot is a default bivariate plot. It is not a univariate. You can use it as a multivariate in case of Seaborn, but here as the PyPlot module dedicatedly used for 2D plottings, so scatter plot we can use for bivariate, scatter, distribution, data distribution. If you want to show, then you can go with the scatter plot. So for scatter plot, I need a data. So I'll use a numpy here, import numpy. Okay, and I want to create random data here. Okay, so I'll use what? np.random. I want 50 values, let's say. Okay, so this random option will create what? An array with the 50 values. I'll give the name here is equal to this. Okay, so this is a name. Fine. And if I want to do the scatter plot, so I'll do what? I'll use here plt dot scatter. In this scatter, you need to supply x-axis value. So I'll supply how many values I'm having. I'm having total 50 values. So I'll directly supply the range 50, and my y is a, means these random numbers. Okay, so these random numbers will be on y-axis, and on x-axis I'll have 50, means 0 to 49, or I'll keep it like 1, 50. So 1 to 50 on x-axis, comma, a means the total random values available or you created using a number. So if you execute this, you will get a scatter plot, and this is a scatter plot which gives you the distribution of your data. It will give you the distribution of your data. Okay. So guys, we have multiple options like to see the scatter plot. So when we want to display, let's say the pattern of data, or my data is a linear or non-linear. So how we can check? We can check using a scatter plot. So the purpose of the scatter plot is to check the data distribution. It is to check the outliers. Okay, means some values those are far away from the distribution or pattern. Those are considered as an outlier. So you can use a scatter plot effectively for checking the outliers. Suppose guys, if I use a linspace option, let's say plt dot scatter, and I'll supply here on x-axis 1 to 51. Okay, and then I'll use here np dot linspace, linearly spaced values, and I'll put here starting is a 2 and stop at 20. Okay, so by default it will also generate the 20 values, and you will get a straight line like this. So linspace will create a linearly spaced values starting from a 2 and 2 to 20. Okay. And index, how much index I'm having here? I'm having an index 1 to 50. Okay. So that's why you're getting here a straight line. Straight line. This first point is starting at a 2, and from this 2, it is again incrementing. Okay, so the purpose of the linspace is what? To create homogeneously spaced numbers. Means the difference between the two successive number is a constant. So there is a constant spacing between the two numbers. For that reason, we use a linspace. Now you get here the line like this. Okay, this is again what? Scatter plot. We have a two graphs, guys. Actually, this graph gives you it's a linear representation, and this is a non-linear representation. So what we are observing the pattern of your data. Non-linear, and this is linear. Rest of the things are same, like plt.x label, plt.y label, plt.title, plt.legend, plt.grid, plt.savefig. Everything is same for all the plots. Okay. Now, guys, after yeah. Okay, linspace. Let me show you. np.linspace. In the linspace, when I'm putting here 2 comma, let's say 10. Okay. So it will generate the values. Those are linearly spaced, whose starting is a 2 and whose end is a 10. So you give here starting is a 2 and end is 10. So starting with a 2, end at 10. But how it will reach from 2 to 10 with linear spacing, with this constant spacing. So guys, if you see the difference between these two values, it is 0.1632. If you check the difference between these two, again it's 0.16, 0.16, 0.16. So homogeneous spacing, linear spacing between the two numbers successively. So this is nothing but what? A linspace. Now you got the point. See, if I check the difference between any two numbers, suppose let's say these two numbers. So if I subtract, then difference is 0.16. If you take any numbers, then difference is 0.16. So homogeneous spacing, constant spacing from one number to other number. Okay. Now, after scatter plot, we are going to see the bar plot. The bar plot is bivariate plot, and again it is dedicatedly used for category versus count plot. Okay, category. Okay, so definitely I need a category and I need a count of it. Okay, so for example, if I write here a company, let's say, is equal to, I'll write here Infi, I'll write here IBM, I'll write here Wipro, okay, TCS, fine. And let's say we have a share. Okay, so I'm going to put here just values. Okay, so let's say 240, 560, Wipro 340, okay, TCS 780, fine. So I'm having a company and it's a share. So one is a category, means company is a category and share is a count. So directly I'm giving the value here. I'm taking the values here. So how we can do the bar plot? plt dot bar, and in this you need to supply category on x-axis. So it is a category versus count. So category versus count means category should be on x-axis and count should be on y-axis. So I'll write here company on x-axis and share on y-axis. Okay. See. Now from this, what you can observe the Infosys is having a list share. Okay, it is low in share. It is last in share, whereas TCS is on the top. TCS is on the top. Second thing, On second position we have IBM, on third position we have Wipro, and on last position is Infosys. Okay. So this is what a bar plot. Category versus count. We have a few questions. Okay. In order to save the graph, we need to go for plt dot save click. Okay. Fine. plt dot save click. And what I'll write here? I'll write here bar dot, let's say JPEG. You can use your valid image extension like PNG, JPEG or JPG. If I execute, then your figure will get stored using the same name you have given here. Go to the parent directory. You can see bar.jpg created seconds ago. If you open it, it will display the image which is available in your Jupyter notebook right now. Now guys, again the same thing, like if you want to change the color, so what to do? I'll copy this. Fine. And color is equal to, suppose if I write here red, so you will get the red color. But again, it is common to all companies, right? If I want to change the color, let's say, if you want to change the color, let's say for each company separately, let's say for Infosys, I want blue, so I use here blue, okay, then red, okay, then for Wipro, we'll take, let's say, cyan, okay, and for TCS, we'll take, let's say, green. So you can have different colors here. Infi, IBM, Wipro, and TCS with the different colors. So as it's a category, we can use it like this. Right? Guys, we have Infi, IBM, Wipro like this, okay? TCS. But suppose if I have a big names, means if I want to change the names, default we have this, but if you want to change the names, okay? Now change X labels. We have a question. Safe is not working with the Colab. Yes, it will not work with the Colab. The reason is the Colab is connected with your tribe. Fine. So on Colab, you need to download that file. So there is a separate operation for download. You can see, you can search for how to download the image on the from the Colab. So you will get one script, and it is IO operation actually. So you can download that. So it is not same as that of Jupyter notebook. It is connected with your tribe. So we need some separate operations there on a Colab. Okay, so it won't work. Now, so if I want to change the X label, so I'll use here plt.xticks. Okay, in this xticks, how many companies we have? We have total 4 companies. I'll write here range 4. And at the place of Infosys, I want to mention here Infosys like this. Okay. At the place of IBM, we need capital IBM. At the place of Wipro, I want Wipro Technology. And at the place of TCS, I want Tata Consultancy. Right? If I execute, then you will get the new labels, but there is one problem. And what is the problem? The problem is here, because Wipro Technology and Tata Consultancy, now there is a problem with this label. So guys, right now your labels at 0 degree. So if you want to add a rotation, okay, even when you add some extra operations or extra options like this, so you may get extra information. You may get an extra information. So in order to skip this extra information, and if you want to display the graph, go with plt.show. Okay. So plt.show will skip the unnecessary data associated with that typical operation, which we don't expect, which we don't want. So we can go with the plt.show. Now, Let's talk about uh, this problem. Okay, so in X6 itself, we have rotation. So we can add a rotation. Let's say I want to rotate this by 45 degree. Okay. So if I execute by keeping the rotation 45 degree, you can see now there is a no problem, and clearly you can understand which graph is with which company, which bar is with which company, and you can notice here the proper things. So lot of things, lot of changes. Again, if you want, I know you might need here a tick like a candle. Okay, you want here a tick, and along with the tick, you want the numbers to be displayed. Absolutely, we can display the numbers. We need to copy some code. Okay, here external text related operations we can write. But first, as a beginner, I would suggest rather you understand what is bar plot, when to use bar plot, what it gives, it comes under which analysis category. Is it univariate? It is bivariate. Otherwise, on day one itself, I said it's open source. So code is freely available. If you just search bar plot using Matplotlib or Matplotlib bar plot, you will get multiple links, multiple websites, multiple codes. If you just copy and if you supply your own data, it will work. It will work definitely. So if your requirement is to get a count here, if your requirement is to make it a dynamic, absolutely we can. So guys, this is a bar plot, but suppose this bar plot is now a vertical bar plot. Okay, I want to make it horizontal bar plot. Fine. So I'll write here. The next thing which I'm going to explain is which we call as a bar H. Okay. So I'll copy this. Fine. And I'll keep everything same. Just we'll change here bar H. What I'll write instead of bar, I'll write bar H. I'll execute. See. Okay. So what you're getting here? You're getting here the labels, but on x-axis we have the problem now because now your category goes on where? It goes on y-axis. So instead of x-ticks, what should I write here? Because my category goes to the y-axis. What should I write here? Y-ticks. Okay. So when you execute and if you change the y-ticks, then it will show you the count on x-axis and the category on y-axis. So this is nothing but a horizontal bar plot. If you think like this width is quite broader, okay, so if you want to reduce this width, so absolutely you can reduce width. Let's say I'll put here 0.8 for example, and I need to check. The bar got multiple incremental width. Okay, so I think we have height here. Yeah, so I can reduce it to 0.4. So you can see now, and default it's a 0.8. Okay, default height is a 0.8 here. So how much height we want to reduce? By 50%. Means 0.8 actual height we have, but I'm making it 0.4. So you'll get a half size of it. So this is guys what horizontal bar plot. Now suppose I want to go for a next plot and my requirement is related to the his plot, let's say. So his plot is a univariate plot which is used to display the range, or it is used to show the range wise distribution of data. Range wise distribution. So guys, if I want to show the range wise distribution, then I need a data where we can put a range. Can anyone tell me any example where we require to categorize them on the basis of range? Any example where we need range option? Hmm? Where we need a range option, let me give you one example. Age group. Very nice. Age group. Okay, suppose if I want to vote, then below 18, not allowed. Above 18, fine. Again, above 18, we have the categories 18 to 35, 35 to 50, 50 to 80, and 80 above. So, this is what? This is a range wise distribution, age wise distribution. Any other example? Absolutely. Student marks means below 40, greater than 40, 45 means 45 to 55, 55 to 65, 65 to 75, and 75 above. Okay. So I'll take the example of marks. Yes, speed, whatever the unit of measurements we have, na? Length, height, weight. So we can club them on the basis of range. Fine. So guys, generate a data of marks for 100 students. Okay. Generate data of marks for 100 students. Okay. So I'm going to generate a data of percentage using a numpy. So I'll use a numpy. So np dot random integer. np dot random integer. Now in this random integer, I'm going to put minimum percentage you need to give here 42. Maximum percentage you can give up to 100 भी मिल जाते हैं. So I'll write here 100. Okay. And how many candidates? For how many candidates? For 100 students. Okay. So the meaning of this bracket is what? Sorry. Let me mention. The meaning of this bracket is 42 means minimum percentage. Okay. Just write here. Minimum percentage. Maximum percentage. And this is nothing but total number of students. Okay. Now execute. Guys, the marks of 100 students randomly generated where the minimum value is 42 and the maximum value is 100. So below 100 you will get the numbers, all numbers. You are not going to get here 100. See, random. Again, if I execute, I'll get new random numbers. See, right now the starting is with 94, 62, 51. If I re-execute this again, let me run it again. I'll get a new number. See, 69, 87, 79. Again, if I run, see, new random numbers. Okay. So as much as if you go on executing, you will get a different random numbers here. Fine. So I'll store it. So it will be again fixed one. So let's say I'll write here percentage. Okay. I'll make it short. Okay. I'll make it short, readable percentage like this. Okay. Now, as I said, histplot is univariate. So you can use plt.hist and you can supply this percentage. Okay. So guys, histplot will give you default 10 objects. How many objects? 10 objects. How? See, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. So 9 and 10. Here we have 2 objects. So total 10 objects. So default, how many artistic objects it will give? It will give 10 artist object. Right? Now, what this indicates? This indicates 42 was my minimum value. Okay, so you can see here 42 was your minimum. Maximum 99, below 100. Okay. So 42, it created its own range by default. Histplot created its own range 42 to 47. How many are there? 10. 47 to 53. How many are there? 7. Okay, here we are having 50 count, 15 count. How it is? 99, 93 to 99. How many students in 93 to 99? 15. How many are there? 87 to 93, 15. Understood, guys? So this is nothing but a count in a particular range. But you may say, sir, they have used their own range. Can we supply our own range? Absolutely, you can supply. Let me show you. So if I want to supply the range, I'll take the help of bins. Okay. And in the bins, we'll supply our own range like 42. Okay. So 42 to 50. Okay. 50 to 65. 65 to 85. Okay. And 85 above. Right? 85 above, or you can write here 99. So now instead of 10 different objects, how many objects you have? Can you tell me? Instead of 10 objects, now how many objects you will have? How many range? 5? 5 or 4? See, this is one object, 42 to 50. Second object, 50 to 65. Third object, 65 to 85. And fourth object, 85 to 99. So range means start and stop, remember. Okay. So when you have 4, when you have 5, then you will have 4 objects. When you have 6 range, then you will have 5 objects. When you have 4 ranges, then you will have 3 objects. Okay, so if I execute, you will have total 4 artist object. Okay, so 1, this is a 2, this is a 3, and this is a 4. Okay, and you can observe again, see, 80 to 100, we have more than 30 students. 50 to 88 something, okay, means 50 to 85. We have given here range 85. So 50 to 85, we have more than 25 students. So result is not bad. It's quite good. So, but the thing is, between 50 to 85, we have most of the candidates. 85 to 100, we have, let's say 99, we have 35 candidates. Okay. So this is the analysis which we can draw. If we have the college record, and if I want to calculate, if I want to analyze the result, if I want to analyze age group, if I want to analyze according to their performance, or if they have the credit points, or if they have some other points. So if you want to analyze, then we can analyze using his plot. Okay. Again, all the things are same. Color, then background, then if you want to make it filled, if you want to make it stepped, multiple options you can do. The purpose of the his plot is to divide or to see the data in range wise format. Range wise distribution you can check. Okay. After his plot, guys, we are going to talk about pie plot. Okay. Pie plot is again univariate plot, and pie plot is used to display the percentage wise distribution. It is used to display percentage wise distribution. How? Let me show you. We have company and we have share. Company and share. Now we have concrete values. Fine. But if I want to convert the whole data into 100%, and I want to find out, let's say this is a share of all the companies. We selected 4 companies, and out of 100%, I need to calculate what was the share of TCS in terms of percentage. If we consider this is 100%, then I want to calculate the share of TCS out of 100%. So I'll go with what? I'll go with the pie plot. So pyplot using plt.py will supply the data of share. Okay. So when you supply the data, it will give you the pyplot like this. Extra information. I don't want this information. I use here plt dot. Okay. Now we gave the share. It is giving you the pyplot. I want to display the percentage of each pie. So we'll use here atopicity. Atopicity stands for automatic percentage. And there is a typical format. Point F or mod F, sorry, not point F, mod F, mod. Okay. If I execute, you'll get the result like this. So the precision value is up to 6 decimal places. But if I want to make it available up to 2 decimal places, I will use here 0.2F. Okay, so you can see here 6 decimal places. So when I put 0.2, so it will restrict up to 2 decimal places. Fine. Now I'm not able to understand which pi is associated with the which company. Actually, it is following the sequence, no doubt. This is a 244 Infosys, 564 IBM, 344 Wipro, 784 TCS. So guys, we'll use here labels is equal to company name. Fine. See. And from this pie plot, you can observe if we consider the whole share as 100%, so the TCS is the only company whose share is maximum among all. TCS share is 40%. The second shareholder is IBM with 29%. Third shareholder is Wipro with 17.71%. And last one is Infi with 12.5%. Okay. So internally, it will calculate the percentage. If we go with the traditional approach, then what we need to do? We need to take the sum of all share. We'll divide each share. We'll calculate the percentage. So you need to perform a lot of operations. But pyplot will do what? Pyplot will make the things very easy. Will make the things very simple. So just you need to give atopicity. It will calculate the percentage. It will display the percentage of a given data of a given feature. And this is again an advantage. Now you may say, sir, can we separate the pies? Because in pyplot we can separate the pie. Can we separate? Yes, absolutely we can separate. So again, another term is explore. How many companies? 4 companies. Okay. TCS is present in the sequence at the end. Okay. So I'll use this 0 for a TCS and I'll explode by 0.2%. So TCS pi, I'm exploding by 0.2%. So if I execute, you can see the TCS pi is exploded by 0.2%. Again, means you want percentage outside, you want label inside, you want to increase the font, you want to change the font style, you want to change the color, you want shade, you want to increase the radius, you want to display the options. Absolutely, you can. So this is what a pie plot. Now, from the Matplotlib, guys, we are going to see the last plot, which is nothing but a box plot. Okay. And box plot is used to detect an outliers. Again, box plot gives you a statistical information about your data. So you have A here with the random values. So if you want to plot a box plot with this example of it for this A, so you can go with plt dot box plot and you can supply the A here. Let me just write plt dot show to display the image. See, so this is the box plot. Now what does this box plot indicate? This box plot indicates different things, like this is the minimum. So minimum is near about 0. Maximum is about 0.8. Then this is what? This is 75 percentile. This is a median. So median is near about 0.4. Then this is the minimum value. Okay, so sorry, this is a 25 percentile and this is the minimum value. The line which is connecting to this box is nothing but a what? IQR. IQR stands for interquartile range. Okay, and here we have actually three quadrants: Q1, Q2, Q3. So this one is a Q1, which is a 25 percentile. This is a Q3, which is median, which is 50 percentile, and this is a 75 percentile of your whole data. This is the minimum value, this is the maximum value in A. Okay. So you can also find out, let's say, A dot minimum. So minimum value is 0.003. Okay. A dot maximum, you can find out it's 0.9. A dot median, sorry, A dot mean. So it is 0.4. So it is near about like 0.4. So you're getting here honestly. And these lines are nothing but the whiskers. Okay. So basically the box plot is used to detect an outlier. Let me show an example. Means if you have data out of a scope, it is not within a range which you are expecting. Those points are treated as an outlier. You can see here. When we combine multiple plots, it will look like this. See. Visible? These points indicates what? It indicates outliers. Okay, outliers, right? So the points which are beyond the limit means minimum and maximum, we have a boundary. If you have more than maximum, if we have less than minimum, then those are considered as an outlier. Okay, so box plot is used to identify it. Even we can see last two columns Z1, Z2, they are at the same level, whereas Y1, Y2 at the same level, whereas X1, X2 at the same level, means their median is the same, here also same, here also same. So we can say these two columns are equal in terms of some properties. Again, it is very important plot from the Matplotlib. Okay, guys. So till now we have seen line plot, scatter plot, bar plot, horizontal bar plot, his plot, then pie plot. Okay, and last box plot.